Like, share and subscribe my channel. So this video I am going to introduce the new chapter of class 12th chemistry, that is alcohols, phenols and ethers. So this chapter first let me discuss the introduction. The alcohols and phenols, okay, those are formed when the hydrogen atom of a hydrocarbon, okay, which is it may be the aliphatic or aromatic respectively, okay, that case which is replaced by the OH group. So that case we can get the alcohols, phenols, okay, that can be obtained. So these class of compounds which can be found, there is a wide applications in the day-to-day life. For example, if you see the ordinary, we are using ordinarily, that is spirit, which is used for the polishing wooden furniture, that is cheaply, which is consisting the compound of hydroxyl group, that is nothing but ethanol. Okay, in case of the sugar, okay, that we are taking through our diet, so that as well as the cotton seed, okay, cotton which we are using, okay, for the fabric, the paper which we are, okay, using for the different purpose, okay, for writing, or all these are made up of the hydroxy group, which are consisting the hydroxy group. Just think the life without paper, okay, such as the no notebooks, books, newspapers, currency notes, checks, certificates, so like these different papers. So all these, if you without these, okay, our life which is not imagined. So means these are mainly, okay, one of the part in our life. The magazines, okay, which are carrying the beautiful photographs, interesting stories, okay, would disappear out of our life if would have been really a different world. Though that will be a completely different world, because the photographs and interesting different kind of magazines, those are consisting the different kind of images, those are consist of different colors. So that is due to the presence of the hydroxy group. So in the alcohols containing one or more hydroxy groups, okay, which are directly attached to carbon atoms, so of an aliphatic system, that case those would becomes under simple alcohols. For example, CH3OH. While the phenols, okay, phenols contains, the OH groups, okay, phenols contains the OH groups, hydroxy groups, okay, that is directly attached to a carbons of the aromatic system, that is for example C6H5OH. So that is nothing but phenol. Whereas the substitution of hydrogen atom in the hydrocarbon by alkoxy or aryloxy group, okay, which yield another class of compounds that is known as ethers. So for this case we can simply take the simple ether, that is CH3OCH3. This is known as the dimethyl ether. So in case of these ethers, okay, the hydroxy group containing hydrogen which replaced by alkyl or aryl group. So that case the another class of compound which can be obtained, that is those are known as ethers. So okay, you may also visualize the ethers are compounds formed by the substituting the hydrogen atom of hydroxyl group of an alcohol or phenol which is replaced by the alkyl or aryl group. So that case we can get the ethers. So this is the simple introduction of the alcohols, phenols and ethers. Okay, next we can go further concept, that is the classification of alcohols, phenols and ethers. Classification of alcohols, phenols and ethers. So in this first the alcohols, if we see alcohols and phenols, if we see, so those are classified depends upon the number of OH groups. Okay, if depends on the number of OH groups, which can be classified mono, di, tri, polyhydric compounds, polyhydric hydroxy groups. So for example, if we see C2H5OH, so in this case only one hydroxy group is present, so it would becomes under the monohydroxy. Whereas if you see this compound, this has CH2OH, okay, CH2OH, so in this case there is a two hydroxy groups are present, so it would becomes under the dihydroxy compound. Whereas in the case of third one, you can see here there is a three hydroxy groups are present on this compound, so it would becomes under trihydroxy compounds. Okay, in case of the aromatic system, in case of the benzene, if it is having the OH group, then it would be comes under the phenolic compounds, which are comes under the phenolic compounds. So those are also consisting either only one hydroxy group, two hydroxy groups, as well as the three hydroxy groups. Those are monohydric, dihydric, and trihydric. That is depends upon the number of OH groups. And these also classified other way, that is, when the carbon which is undergoes sp3 hybridization, to the sp3 hybridized carbon, the OH is bonded to the sp3 hybridized carbon, so which is which is bonding with the different number of carbons. So accordingly, which can be further classified as primary, secondary, and tertiary. So in case of primary, the OH bonded carbon undergoes sp3, which is this carbon again bond with the one more carbon. Then that compounds are known as the primary alcohols. Whereas the OH bonded carbon which is bonding with the two more carbons, so that case it would be comes under the secondary. Whereas OH bonded carbon is bonding with the three carbons, so it would be comes under the tertiary. So this is the classification based on the OH bonded carbon which is bonding with the number of carbons, and at the same time here the OH bonded carbon undergoes sp3 hybridization, which undergoes the sp3 hybridization. Next, another classification. So this is in this case also the OH bonded carbon undergoes sp3 hybridization, but adjacent carbon, next carbon which is undergoes sp2 hybridization. So these compounds are known as allylic alcohols. So in this case OH bonded carbon which undergoes sp3 hybridization, next carbon which is having the sp2, because it is forms a double bond, so it is undergoes sp2 hybridization. So that would becomes under the primary allylic alcohols. Similarly, when the OH bonded carbon which is having the one more bond with the other carbon and another one which is undergoes sp2, so that case it would becomes under secondary allylic alcohol. Next, third one is when the OH bonded carbon which is bonding with three carbons and one of the carbon is undergoes sp2 hybridization, so that would becomes under the tertiary allylic alcohol. Another one is the benzylic alcohols. So in case of this benzylic alcohols, here also the OH bonded carbon undergoes sp3 hybridization, so immediate to the next carbon which is consisting the benzene ring. So if it is the OH bonded carbon has two hydrogens and one phenyl group, that would be comes under the primary benzylic alcohol, whereas the OH bonded carbon having the one more carbon and other one is the benzene ring, so it would be comes under the secondary benzylic alcohol. And other one is when the OH bonded carbon which is having the two bonds with the two carbons and one more phenyl group, so that case that would be comes under the tertiary benzylic alcohols. So all these cases the OH bonded carbon undergoes sp3 hybridization, it undergoes the sp3 hybridization. Next one, the compounds which are containing carbon which is bonded to the OH undergoes sp2 hybridization. So that case we can mainly get two kind of compounds. One is vinylic alcohols, and other one is the phenols. So in case of vinylic alcohols, those are the aliphatic system which consisting the double bond. The one of the, in that double bonded carbon, one of the carbon which is bonded with the hydroxy group. So those groups are comes under the vinylic alcohols. And in case of the phenols, the benzene ring. So in case of the benzene ring, one of the hydrogen which is replaced by the hydroxy group, those are known as phenols. Those are known as the phenols. It may be also consisting some other substances. So all those comes under the phenolic compounds. So in this case, the carbon which is undergoes sp into 2. Next compounds are ethers. So ethers are mainly classified into two kinds. One is symmetrical ethers and other one is asymmetrical ether. Those are also known as the unsymmetrical ethers. So symmetrical ethers, it can consisting the oxygen. So with respect to the oxygen, so either side which can consisting the same kind of alkyl groups or aryl groups which can be present. So those would becomes under the symmetrical ethers. Whereas unsymmetrical ethers, so that case these two groups with respect to oxygen, those are different. So that case that would be comes under the unsymmetrical ethers. So in case of the dimethyl ether, so with respect to the oxygen, so either side if it consists in the same kind of groups, so dimethyl groups, so that case it would be comes under the symmetrical ether. So in this case we can take the example like C2H5 O C2H5. So with respect to oxygen, so both sides which is having the same kind of alkyl group, so that would be comes under the symmetrical ether. Whereas unsymmetrical ether with respect to oxygen, those are having the different kind of groups, so that case it would be comes under the unsymmetrical ether. So here C2H5 O CH3. So this is with respect to oxygen, those are having the different alkyl groups, so it would be comes under the unsymmetrical ether. And other one is C2H5 O C6H5. So this case also it also comes under the unsymmetrical ether, because with respect to oxygen, okay, one side is ethyl group and other side is phenyl group, so those are different groups, so it would be comes under the unsymmetrical ethers. This is about the classification of alcohols, phenols and ethers. The next important topic of this chapter, that is nomenclature of the alcohols, phenols and ethers. So in that first one is the alcohols, the nomenclature of alcohols. So this nomenclature again we can consider for the two kinds. One is common nomenclature and other one is the IUPAC nomenclature. So in case of the common name, okay, the common name which can be derived by the alkyl group to the alkyl group which can be added the alcohol. So accordingly the common name can be obtained. For example, CH3OH. CH3 it is methyl is the alkyl group name, and alcohol we have to add. So the methyl alcohol, that would be the common name for the compound. So simply we can write alkyl alcohol. Okay, this is the common name format. But whereas in case of the IUPAC system, it can be derived based on the alkane name. The alkane at the end E, which is replaced by the OL suffix name, that is with the OL that can be replaces. So it would be alkanol it would become. And the position of the substituents which are indicated by the numerals. Okay, for this case we have to consider the longest carbon chain. Okay, that is known as the parent carbon chain. So that numbering which can be start from the end that is nearest to the hydroxy group, which is the nearest to the hydroxy group, from that end we have to give the numbering. The position of the OH group and other substituents which are indicated by using the numbers of carbon atoms to which these are attached. So which carbon the substituents as well as the hydroxy group is attached, so that number to be mentioned. For the naming of the polyhydric alcohols, so the E of the alkane should become retained, and ending ol, that can be added the number of OH groups which is indicated by the adding the multiplicative prefix. So like di, tri, so tetra, these can be we need to use. In addition to that, we can also mention the numeral value of the position of the particular hydroxy group before the ol, that need to be mentioned. And the position of the OH group, okay, that are indicated by the appropriate locants. For example, in this case OH CH2 CH2 OH, so which is named as ethane 1,2 diol. So here we have to mention ethane at the end E is retained, and 1, 2 the positions the OH group is present, and there is a 2 ols. So because of that we need to mention di, and at the end we have to write ol. So this way we can write the IUPAC names for the alcohols. Okay, there are some of the common names as well as the IUPAC names of some of the compounds of alcohols as given below. Here you can see some of the common and IUPAC names of alcohols. So first one is CH3OH. This compound has the common name methyl alcohol. Methyl alcohol is the common name, where the IUPAC name is methanol. Whereas the second one is CH3CH2CH2OH. This is known as the common name. It has the N-propyl alcohol, and the IUPAC name is propanol. And other compound, if the OH is present at the second carbon to the propane, so that case it would be comes under the isopropyl alcohol, that is the common name, whereas the IUPAC name is propanol. This would be the IUPAC name. So in case of the butane, the first carbon has OH group, so that case the common name would be N-butyl alcohol, and the IUPAC name is butane-1-ol. The same case, the same butane, the second position if the hydroxy group is present, so then that common name for that compound is secondary butyl alcohol, but the IUPAC name is butane-2-ol. Okay, this is the IUPAC name. So in case this compound, we can also write if suppose one more, okay, the structure which is wrong, okay, that is CH3, okay, CH3 C, CH3 CH3OH, so it would be isobutyl alcohol is the common name, and the IUPAC name would be K2-methyl propane-1-ol. Okay, this would be the 2-methyl propane-2-ol, so this would be the IUPAC name. Okay, next other compound, so this case you can see CH3 CH3, it would be CH3. Okay, next CH2OH. So this case, this compound name is isobutyl alcohol, whereas the IUPAC name is 2-methyl propane-1-ol. This is the IUPAC name. And other compound is CH3 CH3OH. So this would be, the common name is tertiary butyl alcohol, which is the common name, whereas the IUPAC name is 2-methyl propane-2-ol. This is the IUPAC name. And the, okay, if it is a multifunctional groups, so for example CH2OH, CH2OH. So this case the common name is glycerol is the common name, and the IUPAC name is propane 1,2,3-triol. This would be the IUPAC name of this compound. So this case, okay, multi hydroxy groups are there, more than one hydroxy groups. So that case the alkane at the end E, which is retained, and we need to mention the position of the hydroxy groups, and depends upon the number of hydroxy groups we have to write the prefix name di, tri, tetra, and at the end suffix name we need to add, that is ol. So this way we can write the alcohols, okay, names, alcohols IUPAC names. Okay, next, in case of the cyclic compounds, okay, cyclic alcohols, so that case we need to use the prefix name is cyclo. Okay, in the case of this you can see here OH which is attached to cyclohexane, this would be cyclohexanol. Okay, this is the name of this compound. And other one is, okay, on the 5-membered cyclic ring, so the one of the carbon which is having the OH group, next carbon has the methyl group. So this case the name of the compound would be 2-methyl cyclopentanol. So this is the IUPAC name of this compound. And other class of the compounds, those are the phenols. Okay, in case of the phenols, the nomenclature which is depends on again the IUPAC system as well as the common nomenclature. So the phenol itself, it is the common name. The IUPAC also accepted the phenol as the IUPAC name. Okay, in case of only one OH group is present, whereas substituents, any substituents which are present, so that case, okay, if it is the substituents which is 1 and 2nd positions, so that case the ortho, okay, we need to take, that is 1 and 2 di substituted, whereas meta 1 and 3 di substituted, that case we need to take meta, whereas para, okay, 1 and 4 di substituted, so that case we need to take para. These are the prefix names we need to use. So in case of this phenol, if you see only one hydroxy groups on the benzene ring, so that would be the both common name and the IUPAC name is phenol. Okay, whereas okay, the benzene ring, one of the CH3 group and OH groups are present, so that case this common name is orthocresol, whereas the IUPAC name is 2-methyl phenol. So among the methyl group and phenol, phenol is the more priority. So the OH group bonded carbon gets the low number. so means lowest number. So it would be the first position, the second position which is having the methyl group. Okay, so 2-methyl phenol. Whereas if in case of this compound, you can see this methyl group which is present at the third carbon, so it would be 3-methyl phenol, whereas the common name is metacresol. And other compound, in this case the methyl group which is at the present at the fourth position, so it would be the common name is paracresol, whereas the IUPAC name is 4-methyl phenol. This is the IUPAC name. Okay, next in case of 2 hydroxy derivatives, okay, that is those are present at the 1, 2, 1, 3 and 1, 4 positions to the benzene. So that case we can write the common name as the IUPAC names as follows. So here the first one is the 1, 2 positions if when the hydroxy groups are present. So the common name is catechol, whereas the IUPAC name is benzene 1, 2 diol. This is the IUPAC name. Whereas the next one is the OH group which is present at the first and third positions. So that case the common name is the resorcinol and the IUPAC name is benzene 1, 3 diol. This is the IUPAC name. Okay, when the OH groups which are present at the first and fourth positions. So this case the common name is hydroquinone, or which is also known as the quinol. These are the common names. The IUPAC name is benzene 1, 4 diols. So here also, okay, benzene at the end E which can be retained when it is 2 hydroxy groups. Next another class of compounds, that is the ethers. Its nomenclature. So it is the common names, okay, which can be derived, okay, from the names of the alkyl or aryl groups, okay, which can be written separate words according to alphabetical order, okay, adding to the word ether. Okay, for example CH3OC2H5. So this is known as ethyl methyl ether. So among the ethyl and methyl, according to alphabetical letters, E come first. So first we have to write ethyl followed by the methyl, and at the end we need to add ether. Okay, if both the alkyl groups are same, so that case we need to use di. Okay, we need to use, okay, di before the alkyl group. Okay, for example C2H5OC2H5. So it would be diethyl ether. Diethyl ether is the name of this compound, diethyl ether. Next another naming system, that is IUPAC naming system. So according to this the ethers which are regarded as hydrocarbon derivatives in which the hydrogen atom of the alcohol group OH group which is replaced by the OR or OAR, that is aromatic ring. So where R and AR are the represented by the alkyl or aryl groups. Okay, these when in the case of the alkyl group length is more, so that case that carbon to be considered as that hydrocarbon to be considered as the parent hydrocarbon. So for this case we can take the examples like CH3OCH3. So this case the common name is dimethyl ether. The common name, IUPAC name is methoxymethane, alkoxy-alkane, methoxymethane. Whereas the next one is C2H5OC2H5. So this case diethyl ether. Diethyl ether is the common name. IUPAC name is ethoxyethane. Okay, these are both these compounds would become under the symmetrical ethers. Next one is CH3O, CH2, CH2, CH3. So this is one is the methyl group and other one is the N-propyl group ether. The common name, IUPAC name is 1-methoxy-propane. So that would be the IUPAC name. Okay, other compound, okay, it is C6H5OCH3. So this is known as methyl phenyl ether. It is also having the common name is anisole. Whereas IUPAC name is methoxybenzene. It also accepted the anisole is the common name for this compound. Okay, next another compound is C6H5OCH2CH3. This is known as ethyl phenyl ether. This is the common name. Okay, it is also known as phenitol. Phenitol is the other name. and the IUPAC name of this compound is ethoxybenzene. Ethoxybenzene is the IUPAC name. Next one is CH3O, CH3. So this compound is the methyl isopropyl ether is the common name, where the IUPAC name is 2-methoxypropane. 2-methoxypropane is the IUPAC name. And other one is C6H5O, CH2, CH3. So this is known as phenyl isopentyl ether. This is the common name. The IUPAC name is 3-methyl butoxybenzene. So this is the IUPAC name. And one more compound is CH3O, CH2OCH3. So this case there is no common name, but it has the IUPAC name, that is 1,2-dimethoxyethane. This is the IUPAC name. And the last compound, that is on the cyclic 6-membered ring, so which is having the 2 methyl groups at the carbon and one more carbon which is having the OC2H5. So this case this compound name would be K2-ethoxy-1,1-dimethyl cyclohexane. So this is the IUPAC name of this compound. Next another topic of this alcohols phenols ether, that is the structure of functional groups. So here the first one is, which is in the case of alcohols, so between the oxygen and hydrogen, hydroxy group which is attached to the carbon, it has a sigma bond, which formed by the overlap of sp3 hybridized orbitals of carbon, with sp3 hybridized orbital of the oxygen. So now this bond angle in case of the alcohols, which is slightly less than the tetrahedral bond angle, that is 109.28 degrees. So this is due to the repulsions between the lone pairs, unshared electron pairs of oxygen. So oxygen has a 2 lone pair of electrons. So between these the repulsions which can be present. Due to that, the bond angle which can be reduced from 109.28 to 108.9 degrees. And at the same time, the bond length between the carbon and oxygen, which is 142 picometers, whereas oxygen and hydrogen bond length is 96 picometers. In case of the phenols, the OH group which is attached to sp2 hybridized carbon atom of the aromatic ring, this carbon, the oxygen bond length which is 136 picometer. In case of the phenols, which is slightly less than that of in the case of the methanol. Methanol has the carbon oxygen bond length is more, it is 142 picometer, but whereas in the case of the phenols, between the carbon and oxygen the bond length is 136 picometers. So this is due to mainly the two reasons. One is the partial double bond character, on account of the conjugation of unshared electron pairs of oxygen with the aromatic ring. So here the oxygen having the pair of unshared pair of electrons, so it is having the conjugation with respect to this ring. So due to that the bond length which is less when comparing with the alcohols in the case of phenols. And other one is the sp2 hybridized state of carbon atom, so that is in the case of this phenol, due to these two reasons the bond length that should become less. In the case of ethers, there is a 4 electron pairs, that is 2 bond pairs of 2 lone pairs of the electrons on oxygen arranged approximately in a tetrahedral arrangement. The bond angle which is slightly greater than the tetrahedral angle, that is due to repulsive interactions between the two bulky alkyl groups, and the carbon oxygen bond length is 141 picometers, which is almost same like the alcohols. So here there is a steric hindrance, one of the phenomena which can be applicable. So due to that the bond length between the carbon and oxygen which is slightly less when comparing with the alcohols, but which is bond angle which is more, that is due to this steric hindrance between this alkyl as well as the aryl group, which can be exist in the case of the ethers. So this is about the structure of alcohols, phenols and ethers. Thank you.